This is section 2, angle relationships in triangles. Today we're going to look at a few rules that are specific to angle measures in triangles. First rule here is called the triangle sum theorem, and it says that the sum of the angle measures of any triangle is 180 degrees. So if you were to add the measure of angle A and the measure of angle B and the measure of angle C, it would always equal 180 degrees. And we talked about this a little bit in that last unit when we were discussing missing angle pictures. So this rule is especially helpful to find missing angles. So this first example here says that after an accident, the positions of cars are measured by law enforcement to investigate the collision. Use the diagram drawn from the information collected to find the measure of XYZ and YWZ. So XYZ. So XYZ is right here, XYZ. XYZ. So we are looking for this angle right here. So I see a triangle. I'm going to look at triangle XYZ, and I am given two angle measures. I need the third. So I need to add together the two I'm given, and that gives me 102. And then the remaining is going to be left over after I take 102 away from 180. So what do I get here? 78 degrees. So the measure of angle Y is 78 degrees. So let me write that out. Measure of angle X, Y, Z is 78 degrees. Okay, second part of the problem says find the measure of YWZ. YWZ is over here. So I'm going to put a little dot here. So if I focus on the bigger triangle, triangle WYZ, the whole thing, I know 40 degrees. I also know all of angle Y. I can add those together. So when I do that, I get 90 degrees. So the entire angle Y is 90. So 90 plus 40 will give me 130. And I know that angle W over here has to be the leftover. So that will end up with 50 degrees. So the measure of angle YWZ equals 50 degrees. Okay, I would like for you to do the U try number 1, and when you get finished, pause the video, and when you get finished, come back and we'll check. Okay, on this U try, first of all, you should have noticed these congruent arcs right here. So the angle I need to find is MJK. MJK. So that is this angle right here. So I want to start over here with this triangle that I have two angle measures given in. So I want to figure out when I do 88 and 48 and take that away from 180, I am left with 44 degrees right here. And because they're congruent, I'm going to put 44 right there. Now that I can do the same process. I can take the 104, add that to the 44, so that's going to be 148, and then when I take that away from 180, I get 32 degrees. So the measure of angle MJK, 32 degrees. Okay, we have a couple of corollaries down here, and a corollary is a theorem whose proof follows directly from another theorem. So corollaries are almost like theorems, like a part A of a theorem. It's sort of like an extension. So first corollary says that the acute angles of a right triangle are complementary. So if I have a right triangle, I know 90 degrees of my 180 degrees is already taken up. So that means the other two angles have to add up to 90, which is where this comes from here. So we could really speed up the process. If we were trying to find angle D or E, we wouldn't have to worry about including the F in our calculation. We could just do angle D plus angle E is 90. Second one is the measure of each angle of an equiangular triangle is 60. So if I know all three angles are the same, and I know that all three angles add up to 180, well, if I take 180 and divide it by 3, I get 60. 60. So that's where that corollary comes from. So you probably could have done that on your own, but that's where it comes from. Okay, moving on. Let's look at a couple examples here off of those corollaries. One of the acute angles in a right triangle measures 2x. What is the measure of the other acute angle? So let's draw a picture. Draw yourself a right triangle. So one of the angles is 2x. What's the measure of the other? Well, I can use my corollary that says that the angle that I need, this one right here, plus 2x will add to 90. Well, I don't want to call it x because the other one's called 2x. So really, the only thing I can do here is I can say, well, I know together they add up to 90, and if I take away 2x, that will give me the other angle. And so that's what my answer is. I can't come up with the answer or the x because I have two things that are missing. Go ahead and pause it, do that you try number 2, and then come back and check. I'm going to sketch a picture here. I have a right angle. One is 63.7. What's the measure of the other? So if you want, we can put an x here. So basically, I know that the x and the 63.7 add up to 90. So I can just do 90 and then take away my 63.7. So the answer will end up being 26.3 degrees. Okay, moving on to exterior. So this says here that the interior is the set of all points inside the figure. So angle 1, angle 2, and angle 3 are on the interior. The exterior is a set of all points outside the figure. So if I were to extend out one of my sides, I would create another angle, and we would call that an exterior angle. So we do have a theorem that goes with that exterior angle. It says that the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior. So the measure of angle 4 is going to be equal to the sum of the measures of angles 1 and 2. Now, if I knew what number 3 here was, we know that 3 and 4 are a linear pair. So if I knew 3, then I would just figure 4 out by finding its supplement. But if I don't know what angle 3 is, I need a way to get to that exterior angle. So let's look at this first example here. It says that find the measure of angle B. So angle B is right here, and notice I have variables on all of them. So this exterior angles theorem says that if I were to take these two remote interior angles and add them together, it will equal this exterior. So that's what I'm going to have to do. So I'm going to have to take the 15 plus 2x plus 3 and set that equal to 5x minus 60. And now I can just work through it and solve it. So I'm going to have 18 plus 2x equals 5x minus 60. So I can take away 2x from both sides. That would leave me 18 equals 3x minus 60. So now we're going to add 60 to both sides. That gives me 78 equals 3x. And then divide off your 3. So 78 divided by 3 gives me 26. So I need the measure of angle B. So angle B is the 2x plus 3. So I'm going to have to plug my 26 into that expression. And so the measure of angle B will end up being 55 degrees. Now, there's no other way I could have figured this out without using this rule because I didn't have the measure of angle C. Okay, I'd like you to try number 3 and then pause it and come back and check your work. Okay, I would set this one up. We're going to do the same thing. We're going to add these two together and set it equal to the outside angle. So I'm going to do 90 plus 2z plus 1 equals 6z minus 9. So I can do 91 plus 2z, 6z minus 9. So I probably will take away 2z from both sides. So that will leave me with 91 equals 4z minus 9. And then I'm probably going to add 9. So that will give me 100 equals 4z. And so then we just want to divide both sides by 100, and we're going to get 25. So z is 25, but I need the measure of ACD. So ACD is the exterior angle right here, this outside angle. So I'm going to have to do 6 times 25 minus 9. So 6 times 25 minus 9, I get 141 degrees. Okay, let's wrap this up. We have one more rule here, and this is called the third angles theorem. So just think about this for a minute, or just listen as I go through this. This says here, backing up, if two angles of one triangle are congruent to two angles of another, then the third pair of angles have to be congruent. So if L is the same as R and M is the same as S, well, when you do all the math and take that away from 180, you're going to get the same value here. So let's throw some numbers in here just so you can see it better. Let's say L is 20. Well, L and R are congruent. That means that one's 20. Let's say M is 100. Well, M and S have to be congruent, so there's 100. Well, when I do 100 plus 20, I get 120. And then if the sum of it has to be 180, that means N has to be 60, and so does T. So you don't have to go through all that work, because if you have two angles of one triangle congruent to two of another, well, the third mathematically will have to be the same. So we're going to use that rule in order to solve equations. So next question says, find the measure of K and J. Well, I see here, actually, if you kind of visualize, you have two triangles that overlap each other. I see here that angle H in the left triangle is congruent to J in the right, and I see F is congruent to I. Therefore, K must be congruent to J. And notice I'm putting extra arcs on them just to show that those are equal in the other, and they're different than the others. So I know here that angle K is congruent to angle J. So I'm going to write an equation, 4y squared equals 6y squared minus 40. So I'm going to solve it. So I'm going to take away 6y squared from both sides. And I get negative 2y squared equals negative 40. Next step is to divide off the negative 2. So divide both sides. That gives me y squared equals positive 20. And the way I undo a variable squared, I come through here and I have to square root both sides. So when I do this, we're going to just key this into the calculator and we're going to come up with a decimal. So we're going to end up with, or actually I'm going to, I don't want to say equals, I want to say approximately, because I'm going to key that in. So I get 4.5. Okay, so we get the value of y is about 4.5. So actually, the other way, if I wanted to leave it exact, I would leave it as square root of 20. Now, the reason I might want to do that is I actually want the measure of these angles here. So I'm going to plug it back into the 4y squared. So when I do that, if I plug it into 4 times 4.5 and then square it, I get, let's see, 4.5 squared, and then times 4, let's see, I get 81. Now, if I leave it as the square root of 20, and I do square root of 20 quantity squared, when I take the square root of 20 and then turn right around and square it, I'm left with 20. So I'm really doing 4 times 20, and when I do it that way, I get 80. Now, I should get the same answer if it's accurate. So the 81 is correct in a sense that it's rounded, but the 80 is actually the more precise answer. So when you are plugging something back into a problem, I would try not to round it very much. So when you go back and do square root of 20, you might want to write it as 4.47213. Write as many digits as you can. So we'll continue to talk about that, but that's one thing kind of to keep in mind. So that's the end of this lesson. If you would go ahead and move on to the assignment and practice through it, and then we'll discuss any questions that you may have next time.